Welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and in this video we are going to actually implement animation, which is one of the most important things in a game. So instead of having a static image that is displayed at all times, we are going to make an animation that will allow, when for example we are shooting our gun, it will allow us to actually see the gun being shot instead of having it just be static. And later on, of course, we can extend this to have animations for enemies and other stuff. So we want, of course, our animation system to work with all different kinds of animations we might have, so it might be useful to make it templated. So I've got this file here called animation.h. Now this consists of a class template called animation, and the reason that we have made it templated is because we can have an animation over many different things. So an animation is just a bunch of collection of different keyframes. As you can see, we've got a struct keyframe here, and each keyframe consists of a time and a value. Now that value can be of any time, which depends on the t template type in our animation. And the reason we do it like this is because we can have, for example, when we are loading our weapon animations, we have got those as SFML textures. However, when we are doing the animation for walls or sprites, those will actually be integers and not textures. So we do not want to have to rewrite the same code. We just want this to be templated so that we can have it work on any type. Since the animation code is not dependent on the value, it's only dependent on the time and the keyframes. The value can be anything. The type of the value is not relevant to how we do our animation. So we can just make it templated and have it work with any value. So as you can see, we've got a constructor for animation here, which just takes a vector of keyframes, and of course we have to put all of this code inside a header because it's templated code. And what we do is we just initialize the keyframes and we set the duration. For the duration, we do actually a bit of a small calculation. So first we check if our keyframes are empty. If they are, then that means the animation basically contains nothing. In that case, we initialize it with 0. Otherwise, we get our last keyframe, and its time is the duration of the animation. And we've got a function called getDuration that returns the duration. In our private variable, we've just got a vector of keyframes and a float duration. Now this is the most important function of the animation, which is the get function, which takes a time, and this returns a value that the animation will have on that time. Now we could implement interpolation for this. However, since we are using basically sprite-based animation in our whole engine, we are only going to need stepping, so we won't have actually interpolating floats. If we want to add that, we can add that later, but here we just need to step. So what we do is we first add 2 checks. If our keyframes are empty, or our keyframes, we've got exactly 1 keyframe. If it's empty, we just return the default value of t, and animation shouldn't be empty generally. And if you only have 1 keyframe, then we return that keyframe's value. Otherwise, we do 2 more checks, which is to check if our time is less than the first keyframe's time, which means that the first keyframe starts at a different time than the time that we have been asked to sample. In that case, we just return the first keyframe's value. Otherwise, if the time is greater than the last keyframes, we just return the last keyframe's value. So it's basically clamped to the first and last keyframes. If that's not the case, then we actually calculate the correct keyframe. So we calculate an index I, and this index I basically represents the, actually we don't really need that. Well, actually we'll just keep that. This index I represents the keyframe that we are supposed to use. So what we do is we run a loop as many keyframes as we have got, and we actually start the loop at 0 as you can see, but we actually go to 1 less than type, the size. This is because we actually don't check whether the jth keyframe is, we don't check if the time is less than that, but instead we use j plus 1. So in the end here we should use keyframes.size minus 1 here, and what we do is we check if the time is less than that time, and if it is, then we set the I to j, and then we just break. We will just loop over all of our keyframes, and when we get the correct time, we will just set that to our value. And so this means that our keyframes should be specified in ascending order, and if they are not in order, this will not work, but we are going to keep them in order. Anyways, once we get our I value, we just get our keyframes at that index, and then we return the value of that keyframe. So as you can see, this code actually does not depend on the value at all. We just need to return that value, so it's not a big deal to make this templated. So now we have also got another class, which is an animator, which is meant to control the animation. So this basically has got the constructor. You can see if I go to actual private member functions, it's got a bunch of these. The first is a value of type t. It is also templated, of course, which is the base value. Now this is just the value that is used if no animation is currently active. So kind of the base texture, you could say. And here we've got a vector of animations of type T here, and that's just the animations that this animator can have. We have got a bool looping, which is false. We have got a size T current here and a float time here. Now this current, of course, is going to represent the current animation, while the time is going to represent the current time of the animator. So here what we do is we initialize here, we just have like take base and animations as an argument, and we initialize the base here and we initialize the animations here, and we initialize the current to -1. -1 means no animation is active, which means we are going to use our base here. And we've also got a function called setAnim, which takes a anim and also a looping boolean. So if this is true, then that animation is looping, and we first make sure that the animation is either -1 to disable the animation, or it's less than the animation's dot size. If it is, then we set the current to this animation, we set our looping to this loop value, and we reset the time back to 0. Now in the update function, what we do is we increase our time by the delta time. So whatever delta time we have, we increase our time by that. And if our current value is greater than or equal to 0, which means that we have got an animation and our time is greater than the current animation's time. So if you've got an animation and our time is greater than the duration of the current animation, then if we are looping, we just subtract the duration from this time so that we loop back to the beginning. Otherwise, we actually stop the animation if we are not looping, and we set our current to -1. Now we have got a get function here, and what this function does is, if our current is equal to -1, it just returns base. Otherwise, it uses the current animation's get function to get the correct value. And that is pretty much all of the code for our animation. And that is, as you can see, this is pretty concise, and we can work with any type. So let's go ahead and open up game.h and look at how this is done. So in here you can see we have got an std array of textures here. This is another array, and this basically contains all of the frames for our weapon fire animation. So if I actually go here, and you can see that we have got basically you can see we have got these 4 new weapon fire 0 through 3, which are just extracted from Doom. These are the actual frames of the animation, so we store those in an array. And then we have got an animator which is operating on SF texture pointer. The reason we use pointer is because you generally shouldn't do a copy. It won't work if we were to just use copy the SF texture. The copy constructor shouldn't be used. We just use a pointer to the texture. So we've got an animator of that type here, and this is the, of course, weapon animator, and this consists of if I open up game.cpp, you can see that when we are initializing this, we initialize this, first of all, we just pass our weapon texture here, a reference to the base weapon texture as the base value, because when no animation is active, we just want to display the texture. Otherwise, we create an animation of the SF texture pointer kind, and for the keyframes, you can see just with increasing intervals, we have got a 1 second long animation here, which goes through the 0, 1, 2, and then 3, the actual indices in the array, and then it loops back down to 0. We have got the 0 duplicated here because the last keyframe actually represents the duration. So if we were to not have this, then the animation would immediately end after the last frame hit, and it would not actually allow us to see the last frame. So we need to actually add that here. This is just a 1 second long animation which displays first all of the frames in ascending order, then in descending. And when we are using this, we first of all, of course, load our array elements from the images, just like we are loading the base texture. And now in here, what we need to do is, as you can see, when we are updating our player, if I open up player.h, now player actually takes a reference to an animator for SF texture, which is the animator of the player, because we need to change its state in player.cpp. So in player.cpp, what I've changed is that I have actually now added a fire timer instead of just having a just fire button, so that we can fire automatically. So here we fire only if our fire timer is less than or equal to 0, and if we fire, we set our fire timer to 1. And whenever we fire, we also set our animation to 0, which is the first animation, which is the fire animation. Otherwise, of course, this is not actually looping, so when this animation is over, the current will get set back to -1, which means we'll again display the base texture. So that's all pretty cool. And in the game update function, we also call our weapon animation.update, of course, because we want to actually update the state of that as well. And in the rendering function, now this is a bit different. So we first get the SF texture pointer with the weapon anim.get, so we get the correct pointer. And if that texture is valid, it should always be valid, but just as a safety measure, we add that. So we create a sprite from that texture and we set the origin based on that texture size. We don't choose the, of course, base texture here, we just use the texture pointer, and then we set the window position, the scale, and then draw it. So now what you should be able to see, if I run make, we can actually now use this, and we can use this to see how our animation works. So if I go ahead and you can see, if I press shoot, then you can see that we actually get that animation displayed of the shotgun shooting, which is all pretty awesome. And you can see that I can shoot at different things. It does detect all of the hits, of course, but I can actually press continuously, and you can see it keeps shooting, and the animation is displaying correctly. So yeah guys, that is pretty awesome. We've got this animation system working, and of course we can just create an animator for int if we want to animate the monsters. So that's really pretty awesome. So alright guys, this is gonna be pretty much it for this video. I'll see you in the next one. Make sure to like and subscribe so you don't miss that one, and share this video with other people as well, and bye.